Homework 16, Exponential and Logarithmic Equations, Video 4, Exponential Equations, Can't Get the Same Basis, Part 2. In between the previous video and this one, I realized that I left off an initial step. So I'm going to call it step 0.5. And I'll illustrate that step as we solve this equation. 7 times e to the 3x power equals 13. Don't take the logs of both sides yet. The reason we take the logs is to apply the power rule. The power rule only applies when the power belongs to the entire argument. But who does this power belong to? Not the 7e, but just the e. So using the power rule right now, taking the log of both sides would not set up an expression where we could use the power rule. In order to do that, we have to isolate the part with the exponent first. And that's what the first step should have been, so we'll call it step 0.5. If necessary, comma, isolate the exponential part. In other words, find the piece that has the exponent and isolate it. The piece with the exponent here is the e, so we need to isolate the e to the 3x by getting rid of the 7. I know how to get rid of the multiplied 7, divide both sides by 7. And we get e to the 3x equals 13 over 7. If that fraction divides cleanly, then divide it, otherwise just leave it there, or if necessary, reduce it. Now we can log both sides using any base. Little word of advice. If you're about to bring out a logarithm of your choice and you have a base of e, you should use ln. If there's an e, use ln. This red marker's about to get thrown in the trash. Off the wall. So we're going to use natural log. So natural log of e to the 3x equals the natural log of 13/7. And remember, the whole purpose of bringing the logs is to use the power rule, which I can use now because this power belongs to the entire argument. Power rule says bring the power down in front as a coefficient. So 3x times the natural log of e equals the natural log of 13/7. And then we finish solving for x. Now before we do that, here's why using natural log was I don't want to say necessary, but it was a darn good idea. Oh look, there's the natural log of e. Do you remember what you're supposed to do when you see that? The natural log of e is equal to 1. That's why if there's an e and you're bringing in a log, you should use ln, because chances are you're going to run into the thing that's equal to 1. Since this is equal to 1, we just have 3x times 1, which equals 3x. And now solving just became a lot easier. I just have to divide both sides by 3 and get x equals the natural log of 13/7 all over 3, which is the exact answer. The approximate answer, just put it in your calculator. And remember, it's your responsibility to know how to use it. Contact me if you need help. So first I got to figure out the natural log of 13/7. So I just put in 13 divided by 7, got its answer, and I'm pressing ln. Now I'm going to divide that by 3. And I get approximately, to 3 decimal places, 0.206. I can check it by putting 0.206 here and seeing if I get 13. 7 times, open parentheses, because I have this type of calculator, 3 times 0.206, close parentheses, e to that power equals, I get 12.99. Pretty close. Alright, so this last one is the last example I was going to show you for solving exponential equations when you can't get the same basis. But the short of it is, get to the part with the power, hit it with the log so you can bring the power down, and then finish solving.